What we're looking at is trace metals and nutrients. So these are two of the biggest pollutants that we commonly find in wetlands. So these wetlands are a big resource for cleaning up the water before it makes its way into Utah Lake. So a lot of the contaminants, which include mercury and other chemicals, make their way into the gutter, into the storm drain, and the storm drains currently aren't treated, at least in Utah. So whatever you put in that storm drain is going to end up right out here. The one we're most interested in is mercury. This inorganic form of mercury, which is relatively harmless, is converted to methylmercury, which is a very toxic form of mercury that bioaccumulates up the food web. So by the time you get to the top predators, you can have pretty high levels of methylmercury, and it can cause serious issues. So we're looking at what are the processes that control the conversion of inorganic mercury, this relatively harmless form, to methylmercury, the really toxic form. And so it just so happens that wetlands are very efficient at producing methylmercury. So it starts with collecting data and doing the science. We take a whole bunch of bottles out to the field with us, collect water samples that we take back to the lab. So Brian is a graduate student who's interested in water chemistry and wetlands. And so he's kind of been taking charge of this project.
So this is what my thesis is about, specifically mercury and methylmercury production in Utah Lake wetlands. I work with Dr. Carling, looking at the results and trying to analyze what they mean. So all the samples come into the lab, and then we analyze the unfiltered and filtered samples, and altering the chemistry and running them through the instrument to get values of mercury. Working with Dr. Carling is definitely preparing me for the future. After finishing school, I want to go work in possibly consulting, doing contaminant hydrogeology. And so he's really good at giving direction on kind of where to go and leading in my research.
I've really enjoyed, my time at BYU. I've enjoyed watching students progress from being students at the undergraduate level to real scientists at the graduate level. It makes me think back about when I was in their position. How did I used to view the world and how do I view the world now? And there is this big shift that occurs when you start actually researching projects and getting into real science. The best relationship is when you have the faculty member and the student working together, and it's not just the professor saying, all right, now go do this, this, and this, and this, but it's the student saying, well, what if I tried this? So if you're able to get kind of some feedback going back and forth, the science really moves forward.